Hello students, today we'll be starting a new chapter called Applications of Trigonometry, or as it's more commonly known as Heights and Distances. Heights and distances. Ooh, forgot the end there. Now, as the name of the two things suggest, we are basically going to be using trigonometry, which we have already studied, and applying it to some problems where we have to find the height of certain objects or the distance between certain objects. So we'll see how using the basic trigonometric angles, sine, tan, cos, etc., you are able to calculate values of certain objects and distances. Before we get into the chapter, there are a few definitions that we need to learn. And the first definition is the definition of line of sight. Now the line of sight, as the name suggests, is nothing but the line that you draw between your observation point and the point of the object. Meaning, if I say that there is a building and I am observing it from a point on the ground over here, and I am observing the top of the building from the point on the ground, that means the line of sight is the line AB, because it is the straight line between my observation point and the point that I am observing. The line of sight is the first and most critical thing to figure out in every question. We will always first join our line of sight and then proceed with the question. The next two definitions are used to solve the question. Now, if you observe, we are assuming this is a straight building. It is standing on the ground in a straight manner. That means that the building makes an angle of 90 degrees with the ground. Fairly logical. So, if I mark this point as C, we can see that triangle ACB is a right angle triangle. And if it is a right angle triangle, it will follow certain trigonometric properties. So, let's assume that the angle BAC is equal to some value theta. This angle is known as the angle of elevation. Easiest thing to remember is that angle of elevation is always created at the bottom of the 2 points. So it doesn't matter whether this is our observing point or this is our observing point. The point is the angle of elevation is always between your line of sight and the parallel at the lower point. So theta is your angle of elevation. Now let's draw a line over here that is parallel to AC. If you go back to class 7, 8 maths, if I have two parallel lines, then AB is a transversal, and the property of a transversal is that alternate interior angles are equal. So if I assume that this is some other point D, then angle ABD will also be equal to theta, and this angle is known as the angle of depression. And just like angle of elevation, the angle of depression is always drawn with the higher of the 2 points. So in this case, B is the higher of the 2 points. So we draw an imaginary parallel line there, create the angle with the line of sight, and we get the angle of depression. It is never this angle. That angle is called the angle with the vertical, and we'll see a question in which we will apply that. But when angle of depression is mentioned, it means this angle, angle of elevation, this angle, and line of sight, line between your observation point, which can be either of them, and the point you're observing, which is obviously the other one. So with this knowledge, let's look at some simple questions. So let's start off with a simple basic question. There is a kite that is tied to a point on the ground. So this is our ground. Let's say that this is the point that our kite is tied to. We are told that the kite is obviously flying in the air. So at some point in time, the string of the kite is making an angle of 60 degrees with the ground. So this is obviously what it would mean. This is the string of the kite. Let's say the kite is over here. This will be the angle it's making with the ground, 60 degrees. We are told that the kite is 100 meters above the ground. The person is a very good kite flyer. They're able to get the kite 100 meters in the air. The question is, what is the length of the string of the kite? So, obviously, when they say the height of the kite above the ground, they mean the perpendicular height. And if we simply name our triangle ABC, the length of the string of the kite is AC. So since AC is the string of the kite, and that is what I need to find, I have this angle, I have one of the lengths of my triangle, I can use certain trigonometry to find the length AC. So what we're going to do is we're going to figure out what is the side that we know, AB, what is the side that we need to find, AC, and what therefore is the trigonometric angle I need to use that relates AB and AC. Now in this case, AB is the perpendicular, AC is the hypotenuse. So sine function is the one that relates perpendicular to hypotenuse. If you remember, sine theta is perpendicular upon hypotenuse. So in this particular case, sine angle C will be equal to AB upon AC. And the good thing is, I know what angle C is. It is 60 degrees. I know the length of AB. It is equal to 100. And of course, AC is the length that I need to find. I also know the value of sine 60. It is root 3 upon 2. So my equation is root 3 upon 2 is equal to 100 upon AC, which means if I cross multiply, I get that AC is equal to 200 divided by root 3 meters. And remember, we will always rationalize. So since I have root 3 in the denominator, I'll multiply with root 3 upon root 3 to give me 200 root 3 upon 3 meters. So the length of the string of the kite is 200 root 3 upon 3 meters. So this is the most basic standard question. We didn't even have to think about angle of elevation, angle of height, because they just told it to us that the angle of the string with the ground is 60 degrees. But this is effectively what we will be doing in the chapter. Now let's look at a few slightly more complicated questions where we will need to, for ourselves, identify line of sight, which angle to use, and so on and so forth. So now let's look at a slightly more complicated question. We are told that there is a river and there is a bridge that has been built across the river. So let's assume that this AB is the river. So the end, the width of the river. So these are what are known as the banks of the river. So AB is the ends of the river. And there is some bridge passing over the river like this. Okay. We are told that this bridge is at a height of 3 meters above the river. Once again, when someone says height, they mean at any point on the bridge, the perpendicular distance is 3 meters. We are told that there is some point on the bridge between the banks of the river, let's say here, such that the angles of depression to the opposite banks of the river are 45 degrees and 30 degrees respectively. Now, angle of depression, always from the higher point. For, let's say that the point is O. For OA, the angle of depression will be over here. And for OB, the angle of depression will be over here. So we were told that one of them is 45 and one of them is 30. Let's assume this one is 30 and this one is 45. The question is, find the width of the river. In other words, find AB, because as I said, AB is our river. So again, now in this question, we have a little bit more work to do. So first of all, in addition to the angles, we were given one other piece of information, that the bridge is 3 meters above the river. So if I draw a perpendicular from O, let us say it meets the river AB at point P. This creates two right angle triangles, OPA and OPB. And the length of OP is 3 meters because the bridge is 3 meters above the river. So this is the information I'm currently presented with. First thing we have to realize is that angle of depression is equal to angle of elevation due to alternate interior angles. So angle OAP will be 30 degrees and angle OBP will be 45 degrees. So now I have my triangles OPA, OPB, I have the length of OP, I even have angles in both the triangles. They've asked us to find the length AB. Now if we look at AB, AB can be found by finding AP and PB and adding them up. And AP and PB can be found from the two triangles. So if I look at first triangle OPA, I know OP, which is my perpendicular. I need to find AP, which is my base. So we will use tan function because tan is perpendicular upon base. So in triangle OPA, tan angle A is equal to OP upon AP. Angle A is 30 degrees. OP is 3 meters. AP is what I want to find. So I end up getting that AP is 3 divided by tan 30 degrees. Tan 30 degrees is nothing but 1 upon root 3. So it turns into 3 divided by 1 upon root 3. Division by a fraction, reciprocal, is 3 root 3 meters. So AP is equal to 3 root 3 meters. Now We will find PB in a similar way in triangle OPB. Tan angle B will be OP upon PB, which means tan 45 is equal to 3 upon PB. Now tan 45 is nothing but 1. So we end up getting 1 is equal to 3 upon PB, which means PB is equal to 3 meters. And now that I have AP and PB, I can get my length AB as 3 root 3 plus 3, which is 3 into root 3 plus 1 meters. So this is the width of our back. So like this, all we have to do in the questions is identify what is our triangle, what is known to us, what do we need to find, and therefore which sine, tan, cos function should I use to get my desired information. So this is one type of question. Let's look at a couple more and get an idea of what all we're going to have to do.